In this question, we've been told that a constant force F acts on a particle P, which has a mass of 5 kilograms, and that force causes the particle's velocity to change from negative 2i plus j to 4i minus 7j. And that's going to take 2 seconds. We've been asked to find the acceleration of P and to write it in ij notation. Well, we've got quite a few values, so we should be able to use SUVAT. We have the initial velocity, the final velocity, and the time. From there, we should be able to get an expression for the acceleration. So let's go ahead and collect those SUVAT variables, remembering we can keep these in vector form and still work with SUVAT. So the displacement is unknown, the initial velocity as a column vector, negative 2, 1. Final velocity as a column vector, 4, negative 7. We don't know, but are looking for the acceleration, and time equals 2. The formula to use is v equals u plus at. We'll substitute in the vectors as they are, and we're rearranging to solve for a. We can subtract u from v, and we get 6, negative 8. And then we can divide by 2 to get an acceleration of 3, negative 4. Once again, we're asked to keep this in ij notation, so we'll just write that as 3i minus 4j. Part B of the question says that we should show the magnitude of F is 25 newtons and find to the nearest degree the acute angle between the line of action of F and the vector j. Well, here we're going to make use of Newton's second law, F equals ma. The resultant force is what we're looking for, and that's going to equal the mass times the acceleration. We need to find the magnitude of this resultant vector. If we apply Pythagoras, we're looking for the square root of 15 squared plus 20 squared. That's the square root of 625, and that is the 25 newtons that the question asked us to show. So we're taking steps to show that's what's happening. The angle. Let's start with a diagram. So a diagram of this force vector is 15 to the right and down by 20. This diagonal line is going to be the force vector. We've been asked to find the acute angle in between j and this force vector. Usually we would find the angle in between j and f, but now it's been specified. Usually we would find the angle in between j and f, and we would rotate from j clockwise until we met f. But now it's been specified that we should go for the acute angle. So we ignore the obtuse and we're going for the acute. Alpha is the angle that we're looking for. Theta is inside the right angle triangle. So it's going to be useful to find theta and use that to find alpha. We have a right angle triangle and we have the opposite and the adjacent labeled. Theta is going to be inverse tan 20 over 15. That equals 53 degrees. We can also see that alpha plus theta are going to equal 90, so I can find alpha by subtracting 53 from 90, and that gets us 37 degrees. So the acute angle in between j and the line of action of f is 37 degrees.